Hi students, in this video, I'm going to do a really quick revision. Supposing you're really running short of time and you're really very desperate, right? So this video is for you. I'm going to do two questions, quick revision on the concepts of similar triangles and area and volumes of similar figures. So please stay till the end. Right, so let's look at questions 1. This is a rather popular questions where a lot of setters, would like to test you on. Right, so in these questions, you are shown a frustum. This frustum is formed by cutting off a small cone VCD from a bigger cone VAB. Right, you can imagine this being an ice cream, and usually at the tip of the ice cream there are some chocolate pieces, right? So you sometimes you may want to just bite off the chocolate part first. So that is what happens if you bite off the end of your ice cream cone. Then what is left is a frustum, all right, as shown in the diagram. So right, so for part A, you asked to find the length of m end, all right. So we'll be using the concepts of similar figure. So how do we use it? So from the diagram, we can see that a triangle VND is similar to triangle VMB. Right, so this triangle is similar to the big triangle. Using all pairs of corresponding angles are the same. How do we arrive at that? You see that we have a 90 degrees here, also a 90 degrees. So that is one pair of corresponding angle. We have a common angle here, NVB, NVD. It's the same as MVB as a common angle. And of course, the third pair of angles has to be the same due to the property angle sums in triangle. All right, so if these two triangles are the same, then we can use the concepts of the similar triangles. And what is that? Yes, we can actually compare the ratio of the corresponding sides. So L here represent the length or the height, okay, of the smaller triangle, right? And H can represent another dimensions. It can be the radius, any two corresponding sides, okay. So in this case here, what we'll be comparing, it's your V end over VM. Why are we comparing Vn over Vm? Because we're asked to find Mn, and Mn here it's Vm minus Vn. Okay, can you see that? So that's the reason why I need to find Vn and also Vm, and that ratio can be compared with your Nd, which is the radius. Why? Because you're given the radius of the smaller cone to be 3 cm and the radius of the bigger cone to be 6 cm. All right. So with these two ratios, let's substitute in the data. So Vm is given to be 8 centimeter, right? From the diagram, or rather not the from the diagram we're given, the Vm is 8, Nd is 3, and Mb is 6. So we can just do a simple cross multiply to find your Vn, right, which is 24 divided by 6, give you 4 centimeter. So therefore your M end will just be 8 minus 4 gives you 4 centimeter. Okay, right, let's look at part B. For part B, we're asked to find the ratio of the area of the upper base to that of the lower base of the frustum. Right, so the frustum, if you were to recall, it looks like this. So the upper base will refer to this part here, which is a circle, and the lower base is also a circle but of bigger radius. Right, so this is how it looks like. The upper base is the one colored in yellow, and the lower base is the one colored in green. Right, so we can actually find the area of a circle using the formula pi r squared. Right, to get 9 pi for the yellow circle And for the green circle, the radius is 6, so that will be pi times 6 give you 36 pi. Right, so the ratio will just be 9 pi over 36 pi. Right, so the 9 pi and the pi will give you 1. 9 divided by 36 will give you 1/4. Right, so since we're asking for the ratio, you have to leave your answer as 1:4. Right, you don't leave it as a fraction. Right, so I need to cross out this all. So the answer is 1:4. Okay, so the last part of the questions you asked to find the volume of the frustum. Given that the volume of the cone VCD is 12 pi centimeter cube. That means you're given the volume of the smaller cone, the cone that you bite off. Remember the chocolate part of your ice cream, right? So that is 12 pi centimeter cube, and you're asked to find the volume of the frustum. Okay, here we will apply this concept, right? That the ratio, when you cube the ratio of the corresponding sides, cube it, that will give you the volume, the ratio of the volume of the two cones, the smaller one and the bigger one. Yes, V1 over V2 is equals to L1 over L2 cube. All right, so it can also be V1 over V2 is equals to H1 over H2. If you're given the ratios of the height, then you just cube the ratio of the height, or you can cube the ratio of the radius. Basically, it's just two corresponding sides. This one represents your two corresponding sides. Okay, here, of course, I'm going to use the radius because I'm given the radius for the small one is 3. The big one is 6. Okay, so I cube it, and I'm given the volume of your cone VCD is 12 pi. So I'm going to substitute in, yes. And then this one here will give you 27 over 216. And you just do a cross multiply, a shortcut that we use it quite often. And you can find the volumes of the cone VAB to be 96 pi. So therefore, the volume of the frustum will be 96 pi minus 12 pi gives you 84 pi centimeter cube. Right, let's look at question 2. Right, so for question 2, you're asked to name two similar figures and give your reason. So when they say give your reason, meaning you have to show proof that the two triangles that you have stated, why are they similar? All right, so from the diagram, right, we can see that the triangle ABC is similar to triangle ADE. Okay, if you look at how I present my answer, you see that I actually arrange it such that the angle correspond to each other. Like angle A of triangle ABC correspond to angle A of triangle ADE. Angle B of triangle ABC corresponds to angle D of triangle ADE. And C correspond to E. Right, so why are they similar? They're similar because, first of all, your angle ABC is equals to ADE. And it's given in the diagram here. Can you see it's given in the diagram here? Right, so it's given in the diagram, therefore you can use it. And the second pair of angle that are the same will be your BAC equals DAC. And here we have to deduce it yourself. And we deduce it as it is a common angle. Common is this angle that it's in triangle ABC is also an angle in triangle ADE. So it's common. Common means I have it, you have it also, so it's common. Just like, you know, I know Alice, you also know Alice. So Alice is a common friend. That's what it means. So therefore, the two triangles are similar using, of course, then the third pair of the angle will be the same using angle sum in the triangle. And hence, we can use this reason that all three corresponding angles are the same, right? To prove that these two triangles are similar. Okay, so once you know they're similar, all right, we can use ratio of the corresponding sides. Okay, so let's look at B part I. Right, so for B part I can just compare AB over AD equals to AC over AE. Right. So once you have arranged the triangles such that the corresponding angles are the same, all right, your life, oh sorry, shouldn't say your life, our job, okay, it's very much lightened, meaning AB will correspond to AD. That means I can compare the ratios of AB with AD, and then AC, okay, will correspond to AE. Right. So the important thing is to arrange it such that the corresponding angles are the same. After that, the rest is easy. Right. So now we can fill in our dimensions for AB, which is the unknown. Basically, this is what we need to find, because then I can use this value to minus away AE to get my BE. Then AD is given to be 6, AC is given to be 8, 6 plus 2 is 8, and AE is 5, so we can do a cross multiply, and I can find my AB to be 9.6, therefore BE is 4.6, so that's part I. Alright, so for part 2, we asked to find the ratio of the area of triangle ABC to the area of triangle ADE. So here involve a second concept involving area of similar figures. So remember in the earlier slides, to find the ratio of the similar figures for the volume, we cube the ratio of the sides. Here to find the area, we square it. Okay, the two triangles are similar, so I have actually drawn it to make it clearer for you. So I can apply A1 over A2 is equals to the square of the ratio of your sides. And of course here I'll be using AC over AE because it's quite clearly that I have these two sides given. Right. And that will give you 64 over 25. Right. Alright, so I need to mention here, alright, this is a quick revision, but quick doesn't mean it's not complete. Right. So far we have only used test for all pairs of corresponding angles are equal. Right. Bear in mind also there are two other tests that you need to revise on, and that is sometimes the triangles given to you, okay, the two triangles are similar. You have to test it based on the ratios of the corresponding sides are equal, meaning if I label the sides as ABC, right, and then the corresponding sides as lowercase abc, right, so big A over small a is equals to big B over small b equals to big C over small c. Right, sometimes you will have to prove it using ratio of the corresponding sides are equal. Sometimes also you will have to prove it such that the ratio of two sides are the same, means this and this the same as this and this, and the included angle. So that is rule number 2. Right, so you need to familiarize yourself with all these 3 different tests for similar triangles. Alright, so that ends the video on this quick revision. I hope you have gained something from it. Thank you.